Recall that rational expressions are things that look like fractions, except instead of numbers in the numerator and denominator, there's polynomials. Just like fractions you can multiply and divide, rational expressions you can multiply and divide, and that's what this video is going to talk about. The way to do it is, if I'm multiplying, like I am here, I multiply the numerators and I multiply the denominators, but that's just going straight into it and multiplying is not the best way to do it. The best way to do it is to first factor. That way you can see if things cancel. So if I do this, the way I would do it is first I would factor everything that I can. This thing x squared minus 6x minus 16, it's the easy version of factoring, where it's a quadratic with a leading coefficient of 1. So I'm just looking for things that multiply to negative 16 and add to negative 6. That's negative 8 and positive 2. On the denominator, I'm looking for things that multiply to 24 and add to negative 11. So I'm thinking x minus 3, x minus 8. X minus 8, there's no way to factor. It's just x minus 8. And x squared plus 5x plus 6, that's x plus 2 times x plus 3. Now that it's factored, multiplying is easy, right? I multiply the top. So I do x minus 8, x plus 2 times x minus 8. I put them next to each other. That's what it means. When things are next to each other in parentheses, it means multiply. On bottom, I do the same thing. There we go. I multiplied them. Woo! The nice thing is now things cancel. I could cancel an x minus 8. I can cancel an x plus 2. Any factor of the numerator that's also a factor of the denominator cancels out. So all I'm left with is x minus 8 over x minus 3, x plus 3. If I have to write the numerator and denominator in standard form, the denominator is going to be pretty easy actually to do. I could FOIL it, or I could recognize that it's a difference of squares, and it'll turn into that. But if I don't recognize that, I could FOIL it. X minus 3 times x plus 3. I do first, outer, inner, last, combine the like terms. X squared plus 3x minus 3x cancels. So it FOILs to x squared minus 9. Not bad. You see, you just factor everything, put it all in one fraction, cancel the common things. This one's a little bit trickier in that it looks like, I just said, oh, I'm multiplying fractions. Here's what I do. Here, that second one doesn't look like a fraction, but we know what's going on. It is a fraction. It's over 1. So I do it the same way, where I factor everything that I can. X squared minus 5x minus 36, minus 9 and positive 4 are that multiplication. X squared minus 49 is a difference of squares. X squared minus 11x plus 28. I do x minus 7, x minus 4. And the denominator is just 1. So I have times 1 doesn't make a difference. I could write the times 1, or I could not. If I go and I cancel my common factors, x minus 7 cancels. Does anything else cancel? No. So I have x minus 9 times x plus 4 times x minus 4 all over x plus 7. If I have to write this in standard form, I'm going to have to figure out what the top multiplies to. To figure out what the top multiplies to, I either FOIL these out and then multiply this in, or I FOIL these two together first and then multiply the x minus 9 in. That's the one I'll do because x plus 4 times x minus 4 will be a difference of squares. I know that's going to turn into x squared minus 16. So then I just have to multiply in x minus 9. When I do that, I make sure I include every possible combination. X times x squared is x cubed. x times minus 16 is minus 16x, minus 9x squared, and plus 144. Standard form, it really has to be written in the other order. It should be written as x cubed minus 9x squared minus 16x plus 144. Again, though, maybe I don't have to write in standard form. A lot of things we do with rational expressions, it's actually better to have it in factored form like that. Now division. Division, the rules for multiplication for fractions and the rules for division of fractions, it just transfers over. I didn't say that right. Division I do with the same rule I have from dividing fractions. I do keep, change, flip, or stay, change, flip, or whatever your Algebra 1 or pre-algebra teacher taught you. Basically, I take my division and I keep the first rational expression. I change division into multiplication, and I flip the next one. What was in the denominator, the x squared minus 7x plus 10, is now in the numerator, and what was in the numerator, 4x squared minus 16, is now in the denominator. Then I go ahead and I do my multiplication. I do my multiplication by factoring everything. I multiply everything on top by everything on bottom. And I cancel out. 4's cancel. X minus 5's cancel. X minus 2's cancel. I think that's it. So I am left with 2x minus 5 over x plus 7 times x plus 2. If the question asks me to write the denominator in standard form, I would write 2x minus 5 over first, outer, inner, last. Means it's going to be 2x minus 5 over x squared plus 9x plus 14. I know what you're thinking. You've been watching this, I've done a few now, and at this point you're going, why does he have to take a step to go from here to here? All he did was he took out that multiplication symbol and wrote it as one big fraction. That's fine, you do that. I'm trying to give a video that shows the whole explanation, so I want to not take big steps, but 100% I would not write this and this as two separate steps. I would just make it all one fraction and put all the parentheses near each other. And that's what I'll do on the next problem. Except not this one. Maybe we'll do it with this one. This one, it's another different one because it's still multiplying and dividing fractions, but now I have fractions in fractions. And what gets confusing here is it's not totally clear what's divided by what. The trick to these is look at the big fraction bar. That's your division. Divide whatever's on top of the big fraction bar by what's on bottom of the big fraction bar. Then it's a little more clear. Then you know you're supposed to do stay, change, flip. Next, I'll factor, which for this problem is not as easy as it sounds. Right? I've got this difference of cubes here, and I know that's not always our best thing. Difference of cubes works by thinking about a cubed minus b cubed, and that factors into two parentheses. The signs I remember with SOAP, S-O-A-P, same sign, then the opposite, then always a plus. In the first one, go a and b. In the second set of parentheses, go an a squared and a b squared. In the middle, I do a times b. So for ours, which is x cubed minus 8, so x cubed minus 2 cubed, I'll replace all the a's with x, all the b's with 2. x minus 2, a squared x squared plus ab x times 2 plus b squared 2 squared. So we made it through it. Difference of cubes, we made it through it. This x cubed minus 8 turns into x minus 2 times x squared plus 2x plus 4. And x minus 1 does not factor. X squared minus 1, difference of squares. I like that so much better than difference of cubes. And x squared plus 2x plus 4, I'm thinking about something that multiplies to 4, adds to 2, can't come up with anything. It's not 1 times 4, that adds to 5. It's not 2 times 2, that adds to 4. It's not any of the negatives, that would add to a negative number. So it's just x squared plus 2x plus 4. I got everything as factored as I can. Now I multiply everything together, and as I promised in the last one, I'm going to save time by just making this into one giant fraction bar and pretending it's all together. I cancel out the common factors. X minus 1, see you later. X squared plus 2x plus 4, it's nice to get rid of that ugly thing. What I'm left with, on top I have x minus 2 times x plus 1. On bottom I have nothing. When I cancel out in a fraction, and I realize that I'm left with nothing, it's really left with a 1. So what I really have is a 1 on bottom, but of course divide by 1 doesn't need to be written. I could just write this. When it's divided by 1, I don't write it. Like 12 over 4, I don't turn it into 3 over 1, I just call it 3. So my answer is x minus 2 times x plus 1, unless I need to write it in standard form, in which case it would be x squared. Outer is going to be 1x, inner is negative 2x, so that together those make negative x, and last will make negative 2. This one, again, is one of these fractions and fractions ones. So what did I say in the last one? I said look for the big fraction bar. Your big fraction bar is your division. This problem is 4x over x plus 6 divided by whatever's below the fraction bar. So divided by x squared plus 3x minus 18. And I do my state change flip. It turns into this. Before it was a 1 on bottom, now it's a 1 on top. I factor. I write it all as one giant fraction, which in this case I'm just going to take it all and do this with it. And then I cancel out my common things. I don't have anything canceling. Sad day. But that's okay. All it turns into is 4x times 1 over exactly what's already there. If I have to write in standard form, I'll have to actually distribute this out. One more. This problem, for the sake of time, I know you're like, oh, do I need to keep watching? Can I turn it off yet? For the sake of time, I'm going to go through it a little bit quickly. I'll use some fast forwarding. It'll look like I'm just writing really quickly. Order of operations says that multiplication and division are kind of in the same level, so I just go from left to right. First, I'll figure out this problem. Then I'll multiply in the 5 over x minus 4. I do some stay, change, flip. Later, I'll multiply by this fraction here in blue. Next, I need to factor everything. The first fraction, nothing factors. The second one, the numerator, I'll use a -4. I'll use a +2. The denominator, let's take out GCF. Oh my god, that's difference of squares. Now that it's all multiplication, I just multiply everything on top. I'm going to do x minus 3 times x minus 4 times x plus 2 times 5 over x plus 2 times 5 times x minus 3 times x plus 3. What cancels? Oh my goodness, everything on top canceled! The only thing that's left is the x plus 3. I'm left with 1 over x plus 3. What a problem. What a beautiful problem to end on. Alright, good luck.